Hello, we are Team Cookie, and this is our GitHub repository. Let's go to our live demo. So if you build AI apps, you already know about the context of the problem. So as the conversation gets longer, you are forced to basically send the entire chat history back to the LLM on every single request, just so that it remembers what's going on. It eats up all your token limits and also spikes your API bills. And it also makes the responses very sluggish. Today I'm going to show you a Lethus. It's a drop-in proxy that sits right between your front end and the LLM. It acts as an intelligent memory manager, dynamically figures out exactly which context is required and which is not. So before I hit the record button, I spent a few minutes chatting with AI. So we already have built a task management API with Node.js and also fixed some bugs. We have also switched from PostgreSQL to SQLite just to make the local testing easier. Normally, if I write something right now, it would cost us around, so if we check the analytics, it would cost around 22,000 tokens. But let's see what Lethus does. So if I write a prompt which is completely unrelated to the current one, it basically says that to ignore whatever we have done and let's build a Python API script. So let's wait for this to finish. So now this is the state log and this is the analytics. Now if you can see that the last turn we saved around 42% of the tokens, and in total the total reduction is 30%. So in much longer chats the savings would be much higher.
So Lethus AI uses two memory layers, that is, one is state log and the other is change log. So state log maintains a summary of the state of the conversation that is updated every third turn, and then change log gets updated every turn. It keeps a track of the changes of the state in the conversation. Next, let's see where to use state log and change log. So we have smart intent classification where there's three types of intents. There's recall, continuation, and new topic. So let's see how each of these are used. Now, suppose the user says, I want to plan a trip to Japan. Now, this is a new topic, so we send a state log to it. After this, the user asks, April sounds good, maybe 10 days. Now, this is a question that is relevant to the previous 2 to 3 questions, so we send the state document as well as the last n terms. After this, the user asks, what budget did we settle on earlier? Now, this is beyond the scope of 2 to 3 turns, so we use recall, where we send the state log as well as the change log. Now, filtering with Z normalization. So we have the change log now. Now, how do we look at the filtering of it? Now, suppose the user sends a query, what database are we using and why? So before the nth query, the user has already had chat history with the LLM. And then first we find the cosine similarity scores of each of these terms, after which we find the mean and the standard deviation. Using this, we calculate the Z normalization score, and we see that there are some positive values as well as negative values. These positive values indicate how relevant they are to the nth query that the user has sent. Next, we have boosted scores. So first, we look at the changelog entries, and we see whether the particular nth turn is there in the changelog entry. If it is there, then we boost that score by +1 and the neighboring scores by +0.3. Next, we use Cadence algorithm to select the optimal span of context. So Cadence adds up the sum of scores and gives us a span which has the most relevant context. Lethus uses Cadence and Z normalization to memory context prune and keep stateless memory. Thank you.